Hello, everyone. I'm Frank Oriana, and I'll be giving a 3-minute talk regarding antibacterial resistance. First, we'll start by talking about the different types of bacteria. We have gram-positive, gram-negative, aerobic, anaerobic, intracellular, mycobacteria, and mycoplasma bacteria. All these different types of bacteria have characteristics that separate themselves from one another. Thus, there's differences in how we approach to treat these type of infections. For example, gram-positive bacteria have thick cell wall called a succulus. So a popular antibiotic used to treat gram-positive bacterial infections is penicillin, which is a beta-lactam antibiotic that targets the bacterial cell wall by inhibiting peptidoglycan production. Peptidoglycan is important for the integrity of the bacterial cell wall and provides rigidity to the cell and protects bacteria from osmotic disruption. Thus, inhibiting peptidoglycan removes all of these functions that are built into the bacterial cell wall. That said, healthcare providers wouldn't use penicillin to treat a mycoplasma bacteria infection due to mycoplasma bacteria not having a cell wall. This highlights why there's different kinds of antibiotic therapeutics, different medicines for different kinds of infections. That said, I want to point out the importance of not misusing antibiotics. People misuse antibiotics when they're taking antibiotics when it's not necessary to. It is an important topic because it can lead to the development of more antibiotic-resistant bacteria. Antibiotic-resistant bacteria will then carry a antibiotic-resistant gene plasmid that can be transmitted from one bacteria to another via transformation, conjugation, or transduction. The antibiotic resistance gene plasmid can cause antibacterial resistance through several mechanisms, such as releasing an antibiotic altering enzyme that inactivates the drug. It could release an antibiotic degrading enzyme, and it can also induce an antibiotic efflux pump that removes the drug from the bacterial cell. An example of antibiotic resistant bacteria would be MRSA. MRSA is a form of staph infection that is resistant to several kinds of antibiotics most commonly seen in and is most commonly seen in people that have been in hospitals or in health centers with an access to a variety of medicines. Due to this, we cannot use typical antibiotics to treat MRSA like if it were another staph infection. This makes it difficult for healthcare providers to combat MRSA using therapeutics, and sometimes providers have to look towards amputating the affected limb to prevent further spread. Having an antibiotic-resistant bacteria makes it harder for us to treat infections. Thus, more money will have to be put into the development of therapeutics capable of combating these newly resistant bacteria. Needless to say, this will make it more expensive to treat as well. And that's all. Thank you.